Hi, I'm Yiting Zhang.
I'm Dong.
I'm Chiao-Wei.
Here's our final project. This project explores the application of RL to the problem of portfolio allocation in stock markets. Here's our reinforcement learning environment. There are 4 definitions. The first one is action. It represents the weight of stock in the portfolio. It's ranged from -1 to the +1. The positive value is a long position and the negative value is a short position. The next one is reward function, which represents the change of portfolio value. And the third one is environment. It's main simulated livestock market with real market data of those 30 constituents from 2009 to 2021. And using OpenAI Dream framework. The last one is state. It means the stock prices of those 30 constituents and pointed from 2009 to 2021. And this is how we set up our Python environment. This is how we download data from Yahoo Finance. And we pre-process data, we add 2 technical indicators, and we take the data from 2009 to 2020 at the training data set and data afterwards at the testing data.
Yeah. So in our project, we employed 2 advanced reinforcement learning algorithms. The first one is A2C, and the second one is PPO. So first, if we want to train this algorithm, we actually have to split the data from 2009 to 2020, like Yiting said, as our training data, and the data afterwards is going to be our testing data. So if you scroll it down, we can actually see in the code here what we are trying to do is to set up the environment. Yeah, the stock prices environment here. And then we can pass it to OpenAI's Dream environment package here. Yeah, and then here we can actually after we set up all the environment and all the packages, we can try to train the first algorithm, which is A2C here. So as you can see, we just set up the number of steps as 5 and learning rate, and then during the training, you can see there's some login message here, and the loss value, the reward is also going up, and yep. And keep going. This is the result of our training. Yeah, and the second method we are using is PPO. So we are also trying to set up as we did for A2C, and we also try to train it with the time steps of 80,000. So the difference between these two, where the first one, A2C, lies in its well-known stability and efficiency. It really allows us to train and trade agent, train our trading agents by utilizing both value and policy updates, and it will ensure more balanced learning. And for PPO, on the other hand, it provides more robust performance by optimizing a surrogate objective function, and it also helps in maintaining a good balance between exploration and exploitation while preventing drastic updates that could destabilize the learning process. So during the whole training process, one of the significant challenges we face is the inherent volatility and also some kind of unpredictability of financial market. So we actually had some issues. We have to put a lot of time to try to tune the hyperparameters to find a more stable reward endpoint. So following is gonna show us show you the result of our training.
Okay. So after we train the A2C model, we can see the result. We backtest our strategy using the Quant2Pound portfolio package, and we also plot the backtesting. And those 3 plots represent 3 different matrices that we use to backtest our policy with the daily return. And as we can see that the green line represent the backtest, and the daily return represent the daily the gray line represent the daily return. And for this plot, the return, as we can see, that is upside down, and but it still performs pretty good. And here are some more advanced metrics that if you are interested, you can dive into it. But due to the time limit, I won't talk about it. And more importantly, here's our algorithm compared with the benchmark performance. As we can see that as the time passed, our return is higher than the benchmark market, benchmark, and is performed really good. And we also calculate the annual return by using our strategy. It can achieve 29%, and the cumulative return can achieve 41%, which is really, really good. And in conclusion, this project underscores the potential of DRL in financial market, highlighting both its strengths and area for improvement. While the model showed impressive results, the complexity of financial market means that there is always room for refinement and adoption. Future work will focus on incorporating more diverse data source and refining the model decision-making algorithm to further enhance its performance.
this whole project is actually inspired and also referencing a lot code and both the paper from the references listed here. So if you are more interested, you can also dive into. Okay, thank you very much.
Okay, thank you.